The next thing that we're going to do is something known as quotient rule. Okay, so quotient rule. In the previous video, we talked about product rule, right? So what in the world is quotient rule? You only use quotient rule when you see a fraction like this. There's something here on top, there's something here below. So I'll just call it top, bottom, okay, or top, below, doesn't matter. Something on top, something below. Obviously, it needs to look like a fraction. Okay? Now, when I mean fraction, I don't mean just numbers. For example, 3 over 4, I know that's a fraction. But referring to something more complicated, it's like 3x squared or whatever. Something over something like that, that's a fraction. Okay? So that's how you recognize when you need to use quotient rule. Well, there's a little bit of bad news about quotient rule. The formula for doing quotient rule is a little bit more complex. So the thing you need to know is that the formula for quotient rule is given to you in exams, okay? Formula is given. But do you know how to use the formula even if we give it to you? That's the thing. So you need to be familiar with using the formula. So how do we use quotient rule? Take a look at this. I want to differentiate this, so dy dx. The steps to doing this are as so. Differentiate the top. Okay? Differentiating the top, I would get 6x multiplied by the bottom, which is x minus 5. Our minus, this time I differentiate the bottom and I get 1. And I leave the top, which is 3x squared. Okay? Divided by the bottom square, x minus 5 squared. Okay, hang on. Let me slow down for you again. What's this one? This one is what happens when I differentiate the top. This one, I keep the bottom, don't touch. Okay? This one here is when I differentiate the bottom. This one is here is when I keep the top. And this one here is the bottom square. So that's my shortcut method of remembering. But honestly speaking, it's still not very easy to remember. And there's another minus sign here as well. It's important to know that this must come before this because of the minus sign. You can't get it wrong. If you mix these two things up, then your answer will be wrong. Okay, so don't mix it up. You got to make sure that you differentiate the top first and then you keep the bottom. One of the stories that I tell my students is, imagine you have a double-decker bed. Okay, this is a bed and this is a bed, and sometimes siblings sleep here, right? So usually the elder one will sleep up here. Okay, the elder one, and the younger one would be down here. Okay, so this is elder and this is younger. So most of the time, the elder one will get priority. The younger one, less priority. Okay, so priority is given to the elder one, which is on top. So differentiate the one on top first, priority. The one at the bottom, less priority. Yeah. Anyway, this is just my story. If you don't like it, never mind. Don't use it. Just make sure you know how to use the formula. Let's continue. What you have to do from here is you just need to simplify this one. So 6x times x, you get 6x squared. 6x times minus 5, I get minus 30x. Okay. Minus 1 times 3x squared minus 3x squared. The whole thing is divided by x minus 5 squared. Now there's no need to open up this. Okay, the one at the bottom, no need to open it up. Just leave it as it is. We rarely require to open it up. But we do require to simplify the top. See, you can still simplify some more. 6x squared minus 3x squared, I get 3x squared minus 30x over x minus 5 squared. I can further simplify this by factorizing out 3x. If I take out 3x from here, I will have 1x left, and I will have minus 10 over x plus 5 squared. This is your final answer. Okay, that's your final answer by using quotient rule. Before I end this video, I want to touch a little bit about this. This looks like you need to use quotient rule. Okay, I've got a fraction, I've got the top, and I have the bottom. But please don't be mistaken. There is no need to use quotient rule for this particular question, because look at what's at the bottom here. All I have is a number, 5. This is not a function of x. Is there any x here? There's no x. There's no x here at all. So if there's no x, there's no need to use quotient rule. This is a very simple question to do. Let me rewrite it like that. Okay, I will write it as 3 over 5, and then I have x squared plus 2 to the power 3. This makes it a lot easier, doesn't it? It's just a number multiplied to a function. So to differentiate this, dy dx, the 3 over 5 I can ignore, and then I'll differentiate this, bring down the 3 right? X squared plus 2, the same thing, the power reduced by 1 becomes 2. Remember to differentiate what's inside here. I get 2x, and then open up the brackets. So this is 3 over 5 multiplied by 6x. X squared plus 2 squared. Open up this further. 18x over 5 times x squared plus 2 over 2. There, done. Very easy. No need to use quotient rule. So what I mean to tell you here is, please be very, very careful when you look at fractions like this. Even though it does look at a fraction, are they functions of x? If they are not, the question is very simple. Don't use quotient rule. Okay? But unfortunately, let's go back to the previous one. If this one here, both are functions of x at the top and at the bottom, you don't have a choice. You have to use quotient rule. Okay? Quotient rule does make your life easier though, so don't be afraid of it. Just be familiar with using the formula. After practicing about, say, 6 or 7 questions, you'll get the hang of it. All you need is practice.